So this is the second lesson in chapter 16. If you are absent, you might want to look at the warm-up, which is page 283, question 2. So last lesson we looked at what's called indefinite integrals, where there's lots of possible answers, and that's the one where we put plus c at the end of our answer. Now today we're going to look at a slightly different integral. We're going to look at something called a definite integral. And what makes a definite integral that is that we have these two limits here. And those two limits allow us actually to find out what the answer is exactly. So we don't need the plus c for this question. And we would read this as the interval between 0 and 2 of 2x dx. Now, what we're actually doing when we're working out a definite integral is you're actually finding out the area between the function and the x-axis. So there is a practical application of why we're actually doing this. Now, if we go ahead and try this question and the integral of 3x squared minus 6x, then we're going to go ahead and integrate this first. So increase the power by 1, so 3x cubed, and then divide by the new power, 3. And 6x to the 1, so increase the power by 1, 6x squared over 2. And then we put them in brackets, and then we put our limits at the end of the question. Now, we can also simplify this here as well, so let's do that. 3 over 3 is going to cancel to 1, and 6 over 2 is going to cancel to 3. Now, once we've done our integration and we have our limits, we plug in the upper limit into this formula, and then plug in the lower limit into the same formula, and then we go ahead and subtract our two answers. So just like this. Plug the 4 into this equation, plug 2 into this equation, and if you want to check the math, you should get 20. So that tells us the area under the graph between those 2 points is going to be 20. Now, same question but with different limits this time. So this time it's between 2 and 0. So I'm going to skip through the first step fairly quickly because that's exactly the same. When we plug 2 in and then we plug 0 in, then we get this. Negative 4 take away 0 equals negative 4. Now, having said that this was area, you've never come across a negative area before. So what might that actually mean? And that's actually what this question says. What does that mean to have a negative area? Go ahead and sketch the graph of 3x squared minus 6x. Now in class I made people factor this and I make a little sketch. We're just going to take a little look on here. So here's the graph of 3x squared minus 6x. Our first part of the question, we actually worked out the integral between 2 and 4. So in other words, we worked out this. And we got an answer of 20. And our second question was, we worked out the area between 0 and 2. So hopefully you can notice there the difference between the two questions. The 20 is a positive area because it's actually above the x-axis. The negative answer we got for the second question was to show that it's below the axis. So it's not really that the area is negative 4. The area is 4, but the negative shows you it's below the x-axis. That's the key part about this. And that's what the summary says for this. If the definite integral is positive, that's the area between the curve and above the x-axis. And if the definite integral is negative, then that means that the area is below the x-axis. Now, one final thing I want to show you is why we don't actually need the plus c. So if I was to integrate all this, and I just put plus c on the end, and I substitute 2 and 0, notice I'm substituting 2 for x, not for c. So I would have a plus c here, and have a plus c here at the end of the question. When I come to evaluate this, I'm going to have c take away c, which actually cancels. So that's the reason why when we're doing a definite integral that you don't need to put the plus c, because it's only going to cancel anyway later in the question. So that will save you a little bit of effort. That should be enough for you to answer the questions in exercise 16b.